And this is lesson 1.8, quadratic formula. We're going to be practicing using the quadratic formula on some quadratic equations. So before we leave this lesson, you're going to be able to solve a quadratic equation using the quadratic formula. And you'll remember that equations that look like this are in the standard form. And so we need to have our equations in standard form, and a cannot be equal to 0 if we want to use the quadratic formula. Now the quadratic formula is kind of like a magic wand, so you're going to be glad to have this in your pocket as a tool that you're going to be able to use to solve and find those solutions. So that means that you're finding the x-intercepts, you're finding roots, you're finding zeros. Remember, these are all different terms for solving. All right, so regardless of whether you can solve it using factoring, remember factoring is what we've been using most recently, or whether you're using graphing. Remember initially we started off graphing some of these quadratics. All right, so we could also use our square root method, which is one of the methods that we've been using also. And we even learned how to use the square root method with negative numbers under the root. Remember, we used imaginary numbers. And then we just recently learned, the most recent thing we were doing was completing the square. Okay, so regardless of whether you can solve it using factoring, graphing, square roots, or completing the square, you can always, always, always use the quadratic formula to find the solutions of an equation. And remember, solutions can also be called roots or zeros. So let's take a look at what the quadratic formula has to offer us. All right, in order to use the formula, you must have one side equal to 0. Okay, so you'll have to check and see if your quadratic equation is set equal to 0, and if not, then you need to do the manipulation of the equation in order to get it that way. So here's our magic wand. This is what we want to make sure we know really, really well. I'll post it in the classroom, and then it's just something that you need to know, of course, for standardized tests and things like that, of course. All right, so you might have already recognized part of this. You see the negative b here, and you see the 2a in the bottom. So you guys recognize negative b over 2a as how we find the axis of symmetry when we're graphing. Okay, so this isn't too far off of what we've been already looking at over this semester. Now the two solutions of an equation is going to be that distance from the axis of symmetry to the right and that distance from the axis of symmetry to the left. Okay, so we're going to have this plus the square root of b squared minus 4 times a times c over 2a. So if, let's just say, for instance, our axis of symmetry happened to be 1. Okay, so if that negative b over 2a came out to 1, and let's say that our solutions ended up being 5 over here and negative 3 over here. All right, and our minimum point, our vertex, is going to be at negative 4. So if this was our graph right here, then basically what we're saying is that the distance from where the axis of symmetry meets the x-axis and our one solution to the left, that is going to be the negative square root b squared minus 4 times a times c over 2a. And this distance from the axis of symmetry over to the rightmost x-intercept is going to be the plus square root of b squared minus 4 times a times c over 2a. Now you don't have to remember that. I just want you to see that from the axis of symmetry over to the one solution is this distance. Okay, so if we had an actual equation and we actually plugged in b and a and c, you would see that. And then the distance from the axis of symmetry over this way is this distance. Okay, so that's why there are two solutions. We know that there is a place on the parabola that is going to cross the x-axis here and the x-axis here, and there's a certain distance from the axis of symmetry that those 2 points are going to take place. And that's basically what we're looking for. We're looking for solutions. We're looking for roots or zeros. All right, and the quadratic formula is going to help us find that in the most simple way. We don't have to do any factoring. We don't have to do any completing the square or using square roots. We just have to simply plug this information in and work our magic. On the back side of your paper, you're going to see example number 1. And I went ahead and wrote the quadratic formula up at the top of your screen there so that we can keep that in mind. Now, for problems B and D, I'm going to have you do those on your own. So this problem here, I'd like you to do on your own, and problem D, you're also going to do on your own. So I'm going to do the 3 problems on the left and just go ahead and follow along, see what you can, grasp from what we're doing in these 3 example problems, and then apply that to those 2 on the right-hand side. So basically, I'm going to do everything on the left, and then I'm going to ask you to do those 2 on the right. Now, the first thing we need to make sure is that our equation is equal to 0. And since it is, we are set to move forward. So all we have to do is identify A, which here is 1. There's no number in front of that x, so we say that it's 1. B is equal to 4, and C is equal to 7. So now that we have our A, our B, and our C, we just simply have to plug it into that formula that we got. And so let's go ahead and do that. So x, and remember, we should have 2 solutions for x because we're looking for 2 places that the parabola, if we were to graph it, is going to hit the x-axis. All right, so we have to start off with b, but we have to make it the opposite of b. So we have to say -4 plus or minus the square root, and now I have to take b squared, which is going to be 16. Remember, 4 times 4 is 16, minus, and I have to multiply this by 4 times a times c. Okay, and then I'm going to go ahead and take 2 times a, which is just 1. And so if you see here, all I've done is I plugged in everything that I needed, and now I'm going to kind of simplify everything down. So -4 stays as it is. Now, what is this under the radical symbol? We have 16 minus 4 times 1 times 7. Well, that's -28, and the bottom is just going to stay 2. All right. Now, if I clean up my square or my radical over here, this whole thing is going to be a square root of -12. So when I rewrite this, I'm going to have x equals -4 plus or minus the square root of -12 over 2. And I know some of you are thinking, oh, that's right, with a negative number under there, that's actually going to become an I of some kind. So let's go ahead and factor just this part so that we can see what we're going to do with that. That is actually the square root of 4 times the square root of 3 times the square root of -1. And anything that has a -1 there, remember we turn that into an imaginary or a letter I. A square root of 4 is just 2, so now I'm going to clean this up for a final time, and x is going to equal the -4 plus or minus. Okay, let's see, what do I have here? I have 2i root 3. Okay, so this is my 2, here's my I, and then I had my root 3, and that's still over 2. Now, I have one last thing that I can do, because this 2 can go into this -4, and this 2 can go into this 2 also. So that means that I need to divide that 2 into the -4, and this really is my final answer now. -2 on top, because 2 goes into -4, plus or minus I, because 2 divided into 2 is just 1, root 3. Okay, so now cleaning up can be a little bit tricky, so you have to know what can divide into what. 2's can divide into anything, a multiple of 2, but just make sure that you don't try to divide that into something under a radical, and you certainly cannot divide it into I itself. But we'll work on more of these problems as we go, and I think you'll get much better at them. All right, so let's take a look at problem C. Now in problem C, it looks like initially we don't have a 0 on this side, so we need to subtract the 5 from both sides. And so that means I'm going to end up with an equation that looks like this. All right, so now I'm going to identify my A, B, and C. A is going to be -1, B is going to be 4, and C is going to be -5. All right, and all I have to do then is plug in all of my information. So that means that I have -4. Let me just say that this is going to be x equals -4 plus or minus. And again, when I square that b, it's going to be 16. Okay, so b squared, 4 times 4 is 16, minus 4, which is part of the equation, times a times c. And this is all over 2 times -1 because -1 is a. All right, now I have to do some cleanup. And if I clean this up, I'm going to have x equals -4 plus or minus. And if you recall here, all of this is going to be a -20, 16 minus 20. And that's going to be over 2. All right, so if you're looking at that radical, the radical is going to end up with a -4 in it. So let's go ahead and rewrite this again. A lot of the time that you're spending is just kind of simplifying, combining, it's not actually, it's just number crunching, really. So plus or minus, 16 minus 20 is going to be the square root of -4. And if you recall, -4 is going to end up being 2i, because the square root of 4 is 2, and I came from the negative part there, and that we turn into an I. So let's go ahead and rewrite this again. -4 plus or minus 2i over 2. Now, if you see the 2 in the bottom, it actually can divide into the -4, and it can divide into the 2. So to simplify our answer, we're going to say that this is -2 plus or minus I. So that is where the parabola would end up touching the x-axis. If we had all real numbers, we can't really say that because it has an I in it, but essentially that's what we're looking for, is 2 places where the graph would hit the x-axis. All right, so this is the last problem I'm going to do on this notes page, but I want you to recognize that we do not have a 0 over here, so I need to subtract 2x to get everything to one side. So if I subtract 2x over here and over here, I'm going to end up with a 0 on the right, which is exactly what I wanted. And now my equation looks like this. Okay, so now A is 4, B is -12, and C is 9. Okay, so by identifying the A, B, and C, we're going to be able to plug all of this into our formula. And I have to take -b, so that's going to be a +12, plus or minus the square root of b squared. Now b squared is going to be 144, because -12 times -12 is 144. I'm going to subtract 4 times 4 times 9. Remember, it's 4 times A times C, and that is all over 2 times 4. 2 times A. Okay, if you use your calculator, 4 times 4 times 9 is actually 144. So if I took all of this, that would be 144. And I'm going to subtract that from 144 so you guys can see what's happening there. 12 plus or minus 0, because 144 minus 144 is 0, over 8. So this really is, we can disregard this. So now I just simply need to reduce my fraction. So x is going to equal 3 over 2. This one ended up being a lot more simple than the first two we did. And what I would like you guys to do is practice what I just showed you. And if you have to, rewind the video or go back to, something on the front page, or find another video online having to do with working with the quadratic formula, please do that. But it is going to be very important that you know how to use the quadratic formula. It kind of solves all of the other issues that you may have had in the other parts or the other lessons that we've done. So now you're going to be working on problem B here and also problem D. Just make sure you get everything to one side and make sure you set it equal to 0 before you begin using that quadratic formula. Make sure you write down some questions, and then we'll have some practice in class tomorrow.